Okay, the correlation coefficient R is a number between -1 and +1. So if R equals like -0.9, that means it's a strong negative correlation. The dots are close to a straight line. On R of like -0.4, that would mean it's a negative correlation, which means it goes down, but there's a lot more spread. It's a weaker correlation. An R of 0 means you can't tell whether it's going up or going down. Okay, and an R of like 0.7, that's somewhat close to a positive linear relationship, but there's still some scatter. Okay, these are all just random estimates. Your computer does the actual calculation for you. So in this problem, they gave us R is -0.974. That's a pretty strong relationship. And what we do is we usually compare that to table values, okay, to decide whether it's strong enough or not. So if you look at the table value, the degrees of freedom, what you need to do is, just like before in statistical tests, subtract the sample size by something. But if you check the degrees of freedom, eventually we just have to start abbreviating because we can't fill out the whole table. It's somewhere between 80 and 90, okay? Remember, with the table values, what you usually do is you take the absolute value of your test statistic and compare it to the table values. So 0.974, the absolute value, is definitely bigger than anything close to what our table value would be. Okay, so our test statistic surpasses the critical value. So we say R is significant. R is significant because it is not between the positive and negative critical values. Okay, so like let's use the degrees of freedom of 80. If you have a degrees of freedom of 80 or something close to it, then that means an insignificant R would be between -0.217 and 0.217, because that's saying that's the range where it's too close to 0 so that we can't make a conclusion. Ours is beyond it, right? We're outside of that range. So our R is significant because it is not between those two values. Let me find same type of thing for this one. Let me see if I can get one where they ask us to calculate. I can show you how to do it in same thing for this one too. No, none of these it looks like they're going to ask you, but just in case it does come up, if you have to create a correlation coefficient, you can use Excel to do it really quickly. Let me just get some random data in here. This is going to be a weird one. But the correlation coefficient type equals correl. Same thing in Excel if you're using that. And then just like before, it wants an X and a Y column. Now with the correlation coefficient, the order actually doesn't matter, but B2 to B6, A2 to A6. That's how you get your correlation coefficient really quickly, okay? Okay, but I don't think they're going to do that in these problems.